Right.
Cool. So friends, today is the first class on the sprint 3, and the topic this week completely we are going to discuss is total 2 topics. One is the 2-pointer technique, and the second topic is sliding window. These two techniques are called optimization techniques, and they are very important with respect to interview point of view. Mainly, these techniques are helpful to reduce the time complexity. Whatever the techniques that we have seen, that we are going to see in this sprint will helps to reduce the time complexity. Helps to reduce the time complexity. So they're often call it as a optimization techniques. Okay. So in that first technique that we will see is nothing but a 2-pointer technique, friends. Very famous and very important technique. So 2-pointer technique, basically 2-pointer techniques are of total 2 types. 2 types, friends, or 2 models basically will be there here. In the first type, type 1. Type 1 and type 2. So in type 1, both 2 pointers will move in a opposite direction. Listen carefully. In type 1, first 2 pointers. See, pointer is nothing but a variable. Pointer is nothing but a simple variable. Okay. So type 1, both pointers moves in opposite direction. Both pointers moves in opposite direction. Whereas in type 2, so here both pointers moves in same direction. So type 1, both will move it in opposite, both will move it in same direction. Like, okay. So we will discuss type 1 first. What are all the possible problems in the type 1 we will discuss, and then we will move on to type 2. Type 2. So in type 1, as I told, both pointers moves in a opposite direction. So friends, I'm going to take one array. Mostly this technique will be applied on the arrays only. So let me take some couple of elements in the array. So assume this is some simple array, and the elements indices are 0, 1, 2, 3, 4, 5, 6. So as I told, 2 pointers, right? So one pointer will be pointing to the first index, that is starting element. Second pointer, I'm going to take R, which is going to point to the last element of that array. Okay. So here L will be pointing to index number 0, and R will be pointing to n minus 1. So which is last element, index number 0. So here if number of elements are 7, then R will point to n minus 1, which is 6, right? So L will be moves like this. L is going to moves like this, and R is going to moves like this. Basically, L will be incremented or R will be decremented. L plus plus or R minus minus. But you should supposed to know when to increment L and when to decrement R. These 2 conditions you should supposed to know. Okay. Now, so I will take some examples. Based on that examples, I'll make this concept clear. So first question I'm going to take is, so 2 pointer, friends, model 1, as I told, both pointers moves in the opposite direction. Okay, now, so L will be incremented and R will be decremented. But when? You should know when. Okay. So with one problem, I'll make this concept clear. So the first question I'm going to take here is, so friends, here we have given one array which is containing total 8 elements. 8 elements will be given to us, and all those elements are 7, 4, 9, 6. Some random elements I have given. Now the question is, find a pair. find a pair. Pair is nothing but two elements. Okay. Whose sum is equal to k. Whose sum is equal to k. So basically this k will be given. This k is given to us. Given. And number of elements are 8. So let me take here k is equal to some random element I'm going to take. Let's say 30. 30. Tell me friends, is there any two elements is there in the given array? If I sum those two, can I get a sum 30? This is sum 30. Tell me, any two elements are there? I have to get a sum 30. Yeah, two elements are present, right? 21 plus 0. So one is 21 is there here and another is 9 is there. Therefore, if I sum 21 plus 9, I will get a sum 30. Therefore, it should supposed to return true. So here the output will be either true or false. Output will be either true or false. If present, if any pair, then you can return true. Otherwise, you can return false. So this is the problem statement. Is the problem statement is clear for everyone? Simple friends. Any two elements has to be there. If I sum, I have to get the given sum k. That is the question. That is the given question. Yes, two elements are there. Okay. How you are going to solve this question? So one simple approach is, since I need two elements, that is a comma b, I am going to take two loops. So one loop will be pointing, maybe I'll explain here. So let me take the same array. Here, number of elements are 8 and sum will be, or k value, 30. Now, I'm going to take two variables, friends. One variable I, which is starting from 0, and I'm going to take another variable j, which is starting from I plus 1. Now, what I will do, I will find out array of I plus array of j. If these sum would have been equal to the given 30, then I'm going to stop my process. So this is first approach, approach number 1. So this is also called as a brute force approach. This approach is also called as a brute force approach. And that approach is nested loops. Nested loops. Okay. Now I will be initially pointing to 0. Now 7 plus 4. First I will fix the 7. Then I will check is there any other element. If I can add with 7, will I get a sum as 30? So first 4 I'll check. If not, I will check 9. If not, I will check 6. So like that, I will keep on repeating, but I won't find any sum whose two value sum is 30. Then I will increment the I value. When I increment the I value, now tell me friends, next index j, should I start from index number 0 or should I start index number 2? J. From which index onwards I have to start? Think careful and tell me. Index number 0 or from index number 2? From index number 2. From index number 2, friends. Why? If you would have been start your j value from index number 0, then what will happen? Every time you have to take sum of ARR of I plus ARR of j. Already when I is equal to 0, okay, so j value is already pointing at 1. And that time you would have already find out the sum of 7 plus 4. 7 plus 4. Now, when I is at index number 1, and if you again point your j to 0, if you point your j to 0, what is ARR of I plus ARR of j? That is 4 plus 7. Right? Which is you have already taken in the last when I is equal to 0. Then again when I is equal to 1, why to point j is equal to 0 again? The sum you have already checked, right? 7 plus 4. And you found out that this is not equal to given sum 30. Therefore, again, why to point I is equal to j is equal to 0 when I is at 1? Not required. So you can always start your j value from I plus 1. I plus 1, friends. Why unnecessary these things? Correct. Therefore, I will start my j value from I plus 1 onwards. Then again, now I am fixing a value 4 and I will try to find out is there any other element is there, so that if I take it that element and I can sum up with 4, I have to get a value 30. Now I won't find any element. Then what I will do? Again, I'm going to increment the I value. Now I will comes here. I will comes here. Then again, J value start from here. Array of I plus array of J. Is sum is equal to 30? No, not equal. Then I will move the J value. Now I will check 9 plus 21. Why? Array of I plus array of J. Now see friends, both sum is equal to 30, right? Therefore, I'm going to stop the process. I'm going to stop the process. Okay. Now how we are going to code this? Very easy, friends. So you can take 2 nested loops and you can code this. So let me take this one here. So for example, function fun, it will take input array, comma, number of elements. So for I is equal to 0, can you tell me my I value in this example, where should I suppose to run? Till 6 or till 7? Think careful and tell me. Till index number 6 or till index number 7? Till 6 only I have to run. Why? If you would have been run I till here now, then J will point to I plus 1. So is it going to take array index out of bound exception? Getting that? Because here J value undefined. Always your J is pointing to I plus 1. So these small things you have to take care. These small things you should be taking care. Okay. Yeah, here we have to pass the K value also, right? Okay. I is equal to 0. So I value has to go in this example till 6 only. When n is equal to 8, we have to run till 6. Therefore, can I write I is less than or equal to n minus 2? Can I write this, friends? Can I write? I have to run till 6, which means till 6. 6 is nothing but 8 minus 2, which is 6. Or if you want to remove this one, you can remove this equal to symbol and you can keep minus 1 also. Both are same only. Both are same. Less than n minus 1 or less than or equal to n minus 2. Both are having same meaning. But I am comfortable writing like this. So n minus 2. Okay. And I plus plus. Okay. Now I have to take another loop inside for J is equal to I plus 1. Can you tell me J value till where I should suppose to run? J value, no problem, friends. Till last element you can run, which means n minus 1. Till n minus 1 you can run, no problem. So J less than or equal to n minus 1. Till that element, last element. So J is equal to n minus 1, you can run. And then J plus plus. Now once it is done, then it is straightforward. If you would have been found ARR of I plus ARR of J, which is equal to the given K, then you can stop the process. You can stop the process by writing return true, and over, friends. Over. For example, inside by this time for loop ends completely. If it is not returning any true, then what does it mean? It means that you didn't find out any pair. Then finally you can return false. Return false at the end. Very simple code. Very simple code, friends. Understood, everyone? Everyone understood this simple thing? Now let us analyze the time complexity. Now, last class, so many examples we have seen based on time complexity. Can you tell me, friends? First of all, dependency, no dependency. Dependency is there. So when dependency is there, I told how to process. If dependency is there, I told how to process it. Correct. But straightforward, I am writing its time complexity will be order of n square. Because same examples we have seen in the last class. Refer that. What about space complexity? Friends? This is time complexity. Space complexity is what? Apart from given array, are we taking any extra space here? No. Here, I, j, these simple variables, they all are constant space, friends. We are not creating any extra array, right, to solve this question. This is the given input array. Therefore, space complexity will be constant. That's why order of 1. Order of 1 is the space complexity. Order of 1 is the space complexity, right? Okay. Now, since it is n square, I mean, it is not good, friends. This approach is not good because it's a simple brute force approach. We are not using any technique here. So in the interview, they won't accept this solution. They'll ask, can you improve? They are going to ask, can you improve? Which means if I am improving means, tell me, think careful and tell me, do I need to increase the time complexity or do I need to decrease the time complexity? If I'm saying improve means increase or decrease? Obviously decrease actually. Why? If the time is less means that is a better solution. Time is less means that is a better solution, which means I have to find out any other solution whose time complexity will be less than n square. Already you told n square solution. Okay. I have to come up with another solution which will be less than n square. Maybe n log n or n, something like this. Can you tell me n or n log n? They all are less than n square or not? N or n log n. They all are less than n square. Can you tell me n cube? Is it less than n square? N cube is. No. No. Okay, less than n square, either n or n log n, anything less than n square you have to take. Can you tell me n square log n, is it better or not compared to log n? Is it better or not? Not, friends, because n square extra you are multiplying another term. Therefore, this is not better solution. Right. So that's why I told time complexity class is very important, friends. Okay, cool. Now we will reduce its time complexity. There actually, friends, this concept of now 2-pointer comes into picture here actually. So I have taken the given input array and let me take another array. Okay, so this is also another array, friends. Very simple technique, understand carefully. So I am going to take the same input array. First step, what I am going to do, step number 1. I am going to sort the array. I'm going to sort the given input array. Okay. If I sort it, what will happen, friends? Who is the smallest element first? I think 4. So 4 will come here and then 7 will come here and 9 will come. No, 6. 4, 6, then 7, then I think 8, after that 9, then 11, then 17, and then 21. 21. Okay, so after screen stops up. Can you see my screen? Okay, so first step is I have sorted the given array, right? Now, second step is we have to apply the 2-pointer technique. We have to apply a 2-pointer, that is model number 1 or type 1 or model number 1, friends. So model number 1 or type 1, what I told, L will be pointing to 0 and R will be pointing to n minus 1. Okay, therefore a variable L which is pointing to index number 0, this is when after sorting, friends, after sorting. Okay, then second pointer R will be pointing to last element. Now here number of elements is equal to 8 and the sum value will be here. How much will take sum will be, let us take 18. Okay, we'll take 18. Okay, right. So how to sort this? A simple 1-line code, friends. You take the given array name and dot sort. So simple 1-line code you can write so that sorting will be done. Okay. Now come here. So I have taken 1 pointer L here, R here. Now what? Now it is allowed, friends. Yeah, yes, allowed. No problem. It's allowed. You can write, no issue. So here I have to take sum of 2 values, ARR of L plus ARR of R. Whatever the sum value is there, we have to compare this sum versus the given, I think this is K value, right? Let us take this is K value. So this versus K value, we have to compare. So whenever if any two parameters or two values when you are trying to compare, basically you will come up with total three cases. Three cases you will get it, friends. So let us try to see what are the three cases. Case number 1 and case number 2 and case number 3. Total three cases. So first case 1 and case 2 and then case 3. What is first? Both can be equal, or I'm going to take whatever this is. This one I'm going to take as a sum. This one I'm going to call as a sum. So whatever the sum, it can be equal, whatever the sum that you are getting, which is equal to K, this is one case, or whatever the sum that you are getting, which can be either less than the K, or whatever the other sum is there, which can be greater than the K. Can you tell me these three cases only possible, right? When you are comparing any two values, more than, is there anything possible? No. So either sum should be equal or less than or greater than. That's it. Okay. Now I'm going to compare first L value and R value. These two sums I'm going to take, friends. When L is equal to 0 and R is equal to at 7. Now let me take sum of these two values. One will be 4 plus other one will be 21. Now what is this sum? 4 plus 21, which is nothing but 25. This is the sum value. Okay. And what about the given K value? Given K value will be 18. Now, which falls under which case? Tell me. C1, C2, C3. Among C1, C2, C3, this falls under which case? C3, right? Because whatever the sum that is there is greater than the 18, friends. Now, what I should suppose to do? Whenever if sum and K are equal, happy. Whenever this sum and K are equal, we are happy. Because we found out a pair. But if this is less than or greater than, then we are not happy, unhappy. That time we should decide, friends. Now I told there are two possibilities are there. One possibility, either you can increment the L or you can decrement the R. Two possibilities I told. Okay. First, let me increment the L value. If I increment the L value, then what will happen, friends? L will be equal to 1 and R will be same. R will be at index number 7. Now I'm going to add again these two. Then what we are going to get it? Index of 1 plus index of 7. That is 6 plus 7. So what is this value, friends? 6 plus 21, which is nothing but 28. This is when I increment my L value. Now let me decrement my R value and let's see what will happen. If I decrement R value, what will happen? L value will be 0 only, no problem. But R value is going to get decremented, friends. Then R value is going to become 6. Now if I take the sum and let's compare what will happen. L is equal to 0, so which is nothing but 4 plus R is equal to 6, which is 17. Now this value will be 21, friends. 21. And initially what is the value? That is 25. So initially my value will be 25. Okay. And you know already sum will be greater than K. Which is you know already. When sum is greater than K, if I increment my L value, I got it is 28. If I decrement my R value, I got a value which is 21, friends. My ultimate aim is to go towards K value, 18. Now this is 25 when my sum is greater than K. If I increment my L value, I got a 28. If I decrement my R value, I got a 21. Which will be better, friends? My target is to go towards 18. If I increment my L, I'm going 28. I'm going away actually. I have to go towards 18, but I'm going away. R minus is better, friends. R minus is better. Therefore, when sum is greater than K, you have to do the R minus. Okay. Then what is the remaining condition? Friends? This is C1. This is C2, C3. If this is R minus minus means remaining is L plus plus, left over L plus plus. See, somebody saying not clear. Please put your brain here. I am going dead slow. I am going dead slow. Kindly pay attention. Otherwise, drop the class. There is no use such kind of students. I cannot go less than this law. I cannot go. I am taking numbers. I am writing everything on the board clearly. Every case by case I am explaining. Still it is not clear, which means your brain is not here. Maybe it is at your girlfriend home. Or listen the video again. Simple. Listen the video again. Okay. One is R minus minus, friends, and second is L plus plus. L plus plus. Okay. Now let's further continue. Let's further continue this. Okay. So I'll take the next slide and I'll explain. So this conclusion is clear with here. Now we'll go to next slide. So this is my L value. L value is here and R value is here. And the number of elements is equal to 8. And the sum value will be, or K value given is, how much K value? 20 K value 18. Okay. So N is equal to 8 and K value will be 21. 18. So friends, when L is at here, 4 plus 21, which is 25. Clearly 25 will be bigger than 18. So let me write one more time. So here, when sum is equal to K, we are happy. No need to do anything. And when sum will be greater than the K, we have to decrement our R value. When sum will be less than K, we have to increment L. These are the clear, these three cases. So case 1, this is case 3, and this is case 2. Cool. So I have to, since here sum value will be big, right? Therefore, I am going to decrement my R value, which means now R will come here. Now next sum, new sum, 4 plus 17. This is again 21. Now 21 will be obviously greater than the 18. Therefore, again, I have to decrement my R value. I have to decrement my R value, which means now this R will be decremented. Okay. Now again, new sum, 4 plus 11, that is 15. 15 will be greater than 18, which means I have to increment my L value because, sorry, 15 is less, right, friends? 15 is less than 18. Whenever the sum will be less, we have to increment my L value. Therefore, initially L is at here. After incrementing, L will comes there. Okay. Next, new sum. This is 6 plus 11. So 6 plus 11, which is 17, right? So again, 17 will be small compared to 18. So whenever sum is small, simply increment my L value. Now I am going to increment my L value. Next, 7 plus 11, that is 18. So which is equal. Happy. Then simply stop. Simply stop the process, friends. Okay, understood everyone? For example, let us assume that, friends, these two are not equal. Let's say if they are not equal, then again maybe depends upon this K value. Either we will increment my L value or we are going to decrement my R value. Till how long I should suppose to repeat this process? Till how long should I repeat this process? As long as they both are not crossing each other, which means condition will be L should be less than R. Okay, L should not cross this R value or R should not cross this L value. If we seen in the boundary in spiral traversal problem, we seen, right? In spiral traversal problem, we have seen that. So whatever I is there, it should not supposed to cross this. Whatever J is there, it should not supposed to cross this boundary. Similarly, here also, friends, they shouldn't supposed to cross. Okay. Somebody is saying, what if they both are equal? Here we are taking ARR of L and ARR of R. I think common sense, put some common sense here. If they both would have been equal, which means let us say L comes here, R comes here, then 9 plus 9, do you get a pair? Tell me, friends, do you get a pair? 9, 9, is there any meaning actually? Is there any meaning 9, 9? We have to get a two values A plus B whose sum should be k, which means two values we have to take. If the both are pointing same element, then where did you get a pair? Where did you get a pair? Correct. Even in brute force approach also, to remove that only, we have taken I plus 1, right? I plus 1, right? Because taking that I and j should not point into same. Similarly, here also, L should be strictly less than R. Okay. Now, let's write a sample pseudocode for this. Sample pseudocode. Okay. So let me take one simple function fun. Okay, so it will take input array, comma, n value and the k value. So first step, what we have to do, friends? We have to sort the array. Remember, you may ask a question, sir, why I have to sort it? If I did not sort, what will happen? If I did not sort, what will happen? So let me take this one, friends. I'll take the same example and I'll explain what will happen if I did not sort. Then let us take this is L value and this is R value. Now this is 7 plus 17. What is this value? 7 plus 17? 24, right? 24 will be greater than 18. Now L plus plus or R minus minus? R minus minus. Okay. Then my R is coming here. R is coming here. Okay. Now here you are lucky that they both are equal. Here you are lucky that 7 plus 18 and you are getting. But always will you give a guarantee? Always will you give a guarantee? No. If that is not, maybe I'm going to take k is equal to, let's say, 23. Or for example, let me take 13. Let me take 13, friends. Let me take 13 and see whether it will work or not. Same example. If I take 13, it will work or not. So this is L and this is R. Now 7 plus 17, 18. So I have to decrement my R. 7 plus 11. Let me take this is. Okay, we will see whether it will comes or not. So 7 plus 11, 18. Again decrement R. 7 plus 8, 15. 15, right? So this is 13. 13. So again decrement the R. 7 plus 21. Again decrement the R. 7 plus 6, 13. They both are equal. Here it is becoming true. Here, one thing if you observe here, last time we are confidently said that since all smaller values on the left hand side and all the smaller values on the other side, so you can confidently say that yes, I can go either L plus plus or R minus minus. But here it is not like that. 9 is present here, again small, again bigger value, again smaller value. Therefore, confidently you cannot say, should I move L plus plus or should I move R minus minus? That's the reason this code will not work, friends. Therefore, mandatorily array dot sort you have to do. Okay. So mandatorily you have to sort. Cool. After sorting this, then second step is L is equal to 0, comma, R is equal to n minus 1. N minus 1. Which means first pointer L will be pointing to the index number 0 and the last pointer R, which is pointing to the last element. Okay. After that, you should write while L should be less than R. L should be less than R. Now, what is the condition? 3 cases you have to write case by case. So let me take sum is equal to ARR of L plus ARR of R. And let's compare, friends. If sum is equal to K, then we are happy. If you are happy means you can simply return true. Nothing. No need to think anything. If sum would have been small compared to K, then what I have to write? If sum would have been small, obviously L plus plus. Then else. Then else R minus minus. R minus minus over. So once it is done, if it is not returning true means, what does it mean? After completion of this complete while loop, if it is not returning, which means there is no pair, then return false. Return false. Okay. So in the question, they can ask true or false. They can ask yes or no, or depends upon the question, but logic will remain same. Sometimes instead of returning true or false, maybe they can ask what I would say, print also, yes or no. Depends. Okay. So this is a while loop starting and ending here, friends. Okay. Let's ignore this statement. And tell me what is the time complexity here. Let's ignore this statement. And from here to here, you consider, tell me what is its time complexity, friends. Simple, order of n. Simple, friends. Here to here, how many times we are running this loop here? One single n time, like extreme case, what might be happens now? L will be pointing to here only, R will be pointing here. Extreme case, either L will go till the last element, that might be one case, or L will be stays here only. Extreme case, R can be comes here, that is another case, or L can be go half and R can be go half. L can be go half and R can be come half. Now this case, L is starting from here, every time it is moving, and n minus 1 times it is coming. Similarly, worst case R, from here it is coming n minus 1, or this is half, this is half. By any case, if you take, it's not going maximum n. N se zyada nahi ho raha hai, correct? Therefore, its time complexity will be order of n. Order of n. Right? Okay, next. Let us see ARR dot sort. ARR dot sort. In last class, I told inbuilt functions. What is its time complexity? Last class, I have written also. I given the notes. ARR dot sort is going to take n log n. N log n. Order of n log n. So n log n. If this is like this means we have to add these two, right? We have to add. So this will be n plus this will be n log n. When you are adding these two, what will be the overall time complexity? Which one is maximum that we have to take? Among these two, this one and this one, we have to consider the maximum. Maximum. Now, what will be the maximum among n and n log n? Obviously, n log n will be maximum. So overall, its time complexity will be order of n log n. Order of n log n. So I hope, is this approach clear, everyone? Now, next is, what if input array is sorted? Then what is its time complexity? If input array is sorted, then you no need to write this line. ARR dots is not required because they already given the sorted array. Tu kya karega sort karke? They already given the sortedness. Therefore, then its a time complexity will be happy order of n. Order of n. Right? So anyone having any doubts? Now you can ask the doubts. I'm going to take. Sir, what if present more than once? No problem. No problem. If it present more than once, no issue. You can return anyone. Okay. So sir, how will get the indices? L comma R will give the indices, right? So L comma R will give the indices. Simple. What if find the index value? Yeah, the L comma R are indices only, right? L and R are indices only. So I think yes. Ask some good questions, but they are form sorted array. How can you know how many pairs are there? Now tell me, friends, how many pairs are there? What I should suppose to change here? Simple. This line can be modified by count plus plus. You can take one count variable here. And this line will be modified by count plus plus. And last line, instead of false, you can return that count. You can return that count. Understood? Actually, you have to think, friends. Before that, you have to think whether this problem can I apply here or blindly any problem you cannot apply. Any problem blindly you cannot apply. Okay, cool. Next question. Second question. Find a triplet whose sum is equal to k. Next question is, you have to find out a triplet whose sum is equal to k, which means you have to get a triplet. Triplet means 3 elements, friends. So pair means 2 elements. Pair is nothing but a 2 elements. Triplet means 3 elements. Triplet means 3 elements. So A plus B plus C plus K. So if you write a brute force solution, what is its time complexity? Can you help me? 3 nested loops we have to use. 3 nested loops we have to use. So obviously, worst case, its time complexity will be order of n cube. Order of n cube. Okay. How? I told 3 loops you have to take. First loop I, which is starting from 0 to here. Tell me number of elements are 7, 8. I value till what index I should suppose to run. Think careful and tell me. I have to run my I till here only. So 0 to 5. 0 to 5. Then J value, where what index number I have to start and what I have to end. I have to start from index number 1 and I have to end at index number 6 only. 1 to 6. What about K value? Where I have to start and where I have to end? I have to start at 2 and I have to end till 7. Till 7. If n is equal to 8, 0, 5, 1, 6, 2, 7. Now sim this, you can easily say. So first loop I start from 0 to n minus 3. N minus 3. Correct now, friends? Till n minus 3 you have to run because 8 minus 5 will be 3. Then J value, index number 1 or I plus 1 I have to write. J value, start from I plus 1 and till n minus 2 you have to run. N minus 2 you have to run. Similarly, K value, J plus 1. J plus 1 to n minus 1 you have to run. N minus 1 you have to run. And inside that, simple. If ARR of I plus ARR of J plus ARR of K is equal to, I think here K already they have given. Na? Maybe here you take a different variable, friends. Maybe I, J, K, L. I'm going to take another variable. Let me take maybe X. Third variable. So X is equal to the given sum K. Then we have to return true. We have to return true. At the end, if dot did not found, you can simply return false. False. Similar to pair only. Okay. This brute force technique, you no need to sort it, friends. There is no need of sorting because you are blindly taking 3 elements now. No need to sort here. If you want to reduce its time complexity, if you want to reduce the n cube time complexity, then you have to sort it. So how the better technique will be? You take this and you have to sort this array. After sorting, what will happen? Now listen carefully. This is the new array, which is sorted one. So first will be 4, 6. So first element will be 4, then 6, then 9. 8 is there, 8 and 9. 4, 6, 8, 9. 7 is also there, right? 7, 8, 9. Then 11, then 17, and then 21. Okay, I have sorted. Okay, 2. So and number of elements will be given 8. So let me take 6 plus 7, 17, 34. So is sum 34 is present? 34 is present here. Yes, right? 34 is present now. 8 plus 9, 17. 17 plus 17 is 34. So what will be the output? N is equal, sum will be 34. What is the output? True or false? True. Why? Because element present now. So sum 34 is nothing but 9 plus 8 plus 17. So this is 17 and already 17. So 34 will be there. Yes, output will be true. Okay. Now, friends, if they given a pair A comma B, A plus B, just a pair only. If they asked you to find out a pair, what is the time complexity here? If they just asked you to find out a pair, after sorting, then apply. So you know already n log n solution. Sometime back only we have seen. We know the solution. That is n log n. Finding out a pair. How to do this? First, you have to sort the given array. And then apply a two-pointer like starting L here, ending R here. And this code you know already. This is for just finding out a pair. That is A plus B. Now the question is finding out a triplet. A plus B plus C. Finding out a triplet. Okay, now? How can we solve this? Right. So here what I'm going to do is I want to find out a triplets, 3 elements I need. Therefore, first of all, I will fix a value here. I am going to take. I will fix my I here. Then I will start my L from I plus 1. And every time R, I will point to N minus 1 only. So here number of elements are 8 and sum is 34. Or let me take this is K. Okay. Now see what will happen. Now I am pointing is 4. Okay. Then L I will point here and R I will point here. Okay. So from here to here, I will apply a 2-pointer technique. Can you tell me, friends, since it is already sorted, from here to here, can I apply my 2-pointer technique of model 1 to get a pair? Yes, I can apply. Sometime back we have seen, now you will get a pair, but I need a triplet. For the third element is required. Where is the third element? That is present here. 4 plus I need a pair. Okay, so total sum will 34. Out of 34, if you remove 4, then I have to get a pair, that is 30. Is any pair is there from index number 1 to index number 7, if I get that sum as 30. Is there any some pair is there, friends? Yes, 9 plus 21 is there. Therefore, it will run a 2-pointer technique. Either L will go like this or R will come like this, and it can return successfully a pair whose value will be 30. It can return, friends. There. For example, let me take this is not 21. Let me take this is 25. Now, can you get a pair? Now, can you get a pair? No, you cannot get it. Which means you fixed this value 4 and you turn out that here to here, you did not get any pair. Then next time what we are going to do, we are going to leave the value 4 and we will check it on the remaining elements. That is nothing but we will leave this I here. We will leave this I value and I will come here. Okay, I'll fix this. And always your L will be pointing to I plus 1, which means here, L. And R will be always points here, which means out of total 3 elements, 1 element is already decided. Now I just need to find out a pair. Since from index number 2 to index number 7 is sorted, okay, from here to here, it is a sorted. And if it is sorted, you know how to get a pair in n log n time. Now, out of 30, 34, if 6 is already done, then I should look about 28. Can I get a 28? Any 2 elements, A plus B, any 2 elements can I get here to here? So the third element 6 is there. Now, can I get it, friends? Can I get a pair 28 from here to here by any 2 elements? Yeah, what are the 2 elements? Index number 5 and index number 6. You will get a pair, which is 11 plus 17. Therefore, you can simply return true. Worst case, if I did not found out, because we have to always think worst case, then what will happen? I will be go to index number 2. Okay. Then again, I have to point my L to here. So another 2-pointer is required, which is n log n. Still, if you did not found out, then you increment your I value Then again L comma R will come here. Okay, another 2 pointer will be required to find out a pair. If not, then I will come here. If not, then I will come here. Tell me, do I need to point my L here? Is it required? Not required. Therefore, this for loop, where should I start and where should I end? My I have to start from 0 and I have to end to n minus 3. N minus 3. That is enough, friends. So start from 0, run till 5. Why till 5? Because L comma R is there to take care about. L is there and R is there to take care. So this is the outer for loop. Inside that you can apply 2 pointer. While where L will be pointing. So L will be pointing at I plus 1 and R will be pointing at n minus 1. N minus 1. And you can write while L less than R. L less than R, and you can write a 2 pointer code here. This is same only. Whatever the 2 pointer code that I have written, which is same. Only thing is extra outside for loop will be there. Extra outside for loop will be there. Okay. Worst case, you know already this while loop code is going to take n time. Correct? N log n time. We know already this code is going to take n log n time. N log n. Like that, how many n log n's you are doing here approximately? Approximately n minus 3 n log n's you are doing. So can I write roughly this is n? Approximately can I write that is n? Okay. Then overall what will be its time complexity? Since inside for loop, another nested loop is there. Therefore, overall its time complexity will be n into n log n. So n into n log n. So it is nothing but order of n square log n. So understood, friends? Why n log n? It should be n for pair finding rate. Why n log n? Finding a pair, it should be n, right? Okay, good question. Tell me, friends, here, do we require to every time sort the array? Every time is it required to sort or just one time? One time, right? So one time you sort and apply. Therefore, every time is it require n log n or just n? Once only, right? Therefore, finding a pair, it will be just n only. Every time you don't sort, one time sort. It's just a one time sort. One time sort, n log n. And inside, n time finding out a pair. Therefore, its time complexity will be order of n squared. Right? Is this clear? Okay, just one, you sort out of this for loop, simply written one time sort. Okay, before this for loop, I'll write it here. Here, first of all, I have to sort the array. ARR dot sort. Okay, and this time will be n log n. After sorting, you have to apply this. After sorting, write a code. So R L I starting 0, running till n minus 3 and L comma R. Now this is n log n. Total overall time complexity I am writing here. Overall time complexity. First, you have to sort n log n. First, you have to sort n log n. Plus n into n, n square, n into n. Then overall, what is this time complexity? N log n plus n square. Who will be big? N log n plus n square. Who will be big? Obviously, n square will be big. Therefore, order of n square. Now, is this clear? Now, why it is n square? Right? Okay. Now, will you able to implement this? Pseudocode. What pseudocode you need? Tell me. I told everything. I told here complete code for this code. Find a pair. And I told what is exact logic also. I is starting from where, ending at n minus 3. Inside that you keep L here, R here. Can't you write this? Can't you write? If you can't write this, then forget about becoming a software engineer. If you can't able to write this one, then I'm openly telling, if you want to say like we are demotivated, you people say no problem. If you can't able to implement this, then you forget about becoming a software engineer. Straightforward I'm telling. Straightforward I'm telling. Okay, cool. Now, what is the time? Do you want break? Do you want break? Okay, so take a break, friends. We'll meet at 10:35. We will meet at 10:35. Okay, so friends, we'll discuss the next question, that is separate zeros and ones. Listen this question carefully. So here they have given an array. So total 13 elements are there. Number of elements are 13. What you need to do is you need to separate all zeros at the beginning and all ones at the end. Listen carefully. Okay, so all zeros on the left hand side we have to push. So total how many zeros are there? 1, 2, 3, 4, 5, 6, 7, 8 zeros are there. So we have to keep all the zeros at the beginning. Total 8 zeros, and all the ones we have to keep at the end. All the ones we have to keep at the end. So this is the final output array. Final output array. Okay. So one simple solution is, people are saying I can use ARR.sort. ARR.sort. What is this time complex difference? ARR.sort. N log n. If let's say same question, if you same question, same answer, if you replied it in the interview, okay, tell me, do you think you are going to get shortlisted? You are going to get shortlisted? Or let's say you had a company and you are interviewing me. You had a company and you are interviewing me. If I this same answer AR.sort. So what is the reply? We'll get back to you. Reply is we will get back to you. Okay, then they never get back. Here actually ARR.sort is doing the thing here. You are not doing anything there. Everything is taken care by the sort function. Then what you are doing there? Simply everything is done by sort only. Correct? So these kind of solutions we should not say it in the interview right now. If you are using this sort array, and if you are doing something means, then you can sort that array. Then it is applicable, because last problem, if you say you have sorted, after sorting you are doing some work actually. But here after sorting your solution is over. So just in one line solution, right? You are not doing anything there, right? These kind of smart solutions, you cannot say it in the interview. Okay. But then can you tell me, is there any other better solution is there? Okay. So another one solution might be possible is, maybe you can take zero array and you can take one array. So you take simple loop. Whenever if ARR of I is equal to 1, then you push that element into one array. And whenever if array of I is equal to 0, you can push that ARR of I into 0 array. After that, you can combine both of these two. Understood this approach? Merge, something like. With this, what will be it's a time and space complexity, this approach? Or concatenation? Yes, concat. So time will be order of n, no doubt in that. Time complexity order of n, because only one loop you are trying to use there. What about space complexity? Think careful and tell me, friends. What about space complexity? Here, worst case, you are creating an extra array, right? Zero array. So worst case, either zero array or one array can goes to order of n space. Therefore, space complexity will be order of n. order of n. Understood, my friends? Now, okay, so this is one possible solution. Maybe up to somewhat it can be acceptable. Better than that sorting technique, right? Somewhat better this is. But can you further better this? Can you further optimize? That is, can you reduce the space complexity? Can you reduce the space complexity? Yes, friends, we had a two-pointer technique. We had a two-pointer technique to solve this question. So listen carefully. Listen carefully. This is my final expected output. All zeros came at the beginning and all ones came at the end. So 2 pointers, 1 pointer is taking at index number 0, another pointer I'm taking at the last index. Okay. Now, all zeros has to be come in the beginning. That is our target. But first start from the L side. Start from the L side. This is 1. Is it required? 1? No. This one shouldn't supposed to present here. Then you stop here. Now go. Now you check this is R value. Now check this is R value. Here, what is the value that is expected to be present here? 0, right? But the value that is present here is 1. But the value that is present is 0. So you simply swap this one and this one. If I swap, what will happen? So here 0 comes and here 1 comes. 1 comes. Then increment the L and decrement the R. Because over this one, this is over. Therefore, I will increment my L and I will decrement my R. So which means R will comes here. Next, again, you compare, you check. Is it the correct element that is present? No. Here expected is 0, but 1 is present. Then stay here only. Don't move. Next, here you check. Here, what is the expected? 1. But the element that is present is 0. Therefore, it is in wrong. Then swap this one and this one. Then what will happen if I swap? Whatever this 0 will be comes here and whatever this one will goes there. After swapping, then increment L and decrement R. Now my L goes there, then R comes here. Okay. Now again start from the left side. Now here, is it correct position this 0? Yes. Because we need 0, therefore 0. Then you increment my L. 0, yes, no problem. 0, no problem. Increment L, 1 problem. Therefore, if you see L from here to here, you have stopped here. Why I have stopped here? Actually, I am going to take one for loop and I am going as long as if the input is equal to 0, no problem. Okay, as long as if array of L is 0, I have no problem because I am expecting zeros on the left hand side. If you see my output on the left hand side, all zeros are there. And on the right hand side, all ones are there. So as long as if the input is 0, no problem for me. I will keep on incrementing my L value. As long as on the right hand side, ones are there, no problem. I will keep on decrement my R. But problem is on the left hand side, if 1 is there, then the problem. On the right hand side, if 0 is there, that is the problem. Therefore, I am swapping this 0 to here and I am swapping this 1 to here. So that finally, all zeros will be present on the left hand side and all ones present on the right hand side. Okay, cool. Now, from here, I will continue the process. I will continue the process. So finally, my L came here. Now, same, I will go on the right hand side also, friends. Now, if this is 1, I will keep on decrement, but this is 0, na? So problem. I am going to stop here. Now, again, swap this one and this one. So if I swap, 0 will come here and then 1 will goes there. 1 will goes there. Okay. So next, L will be incremented and R will be decremented. Now, this is 1, therefore problem, friends. So stay at here only. But this is 1, no problem. You can decrement your R value. This is 0, therefore problem. So swap this one and this one, which means 0 will comes here and then 1 will goes there. So when I swap, you can increment your L and you can decrement your R. You can decrement your R. They both are meeting same, then stop the process. Both are meeting, stop the process. Stop the process. Okay. At the end, if you see 0, 0, 0, 0, 0, 0, 0. All zeros came at here. That is what we need. And all ones came at the end. All ones came at the end. Correct, now? Right? So whenever, as long as L is less than R, we will keep on running this process. running this process. So let me show the pseudocode here. So how this is working. So I'll take one array here. So array who's containing some elements. Okay. So function fun. So it will take input array and what is its size, right? Now I will take L is equal to 0 and R will be pointing to N minus 1 friends. So while L less than R, we have to run the process. Okay. It is here is important thing. Kindly observe, concentrate here. Now see this friends. So L I am pointing here and R I am pointing here. Okay. So if it is equal to 0, no problem. You can increment your L. If it is equal to 0, no problem. If it is equal to 0, no problem. Increment. But when it is equal to 1, you have to stop. Am I correct? Am I correct, friends? So as long as if for all the left side elements are 0, no problem. You keep on increment or left pointer. But when you see the first one, you have to stop it. Why I have to stop? Because here I am expecting 0. L corresponding to 0 and R corresponding to 1. Therefore, I will write inside this while loop. I am going to take another while loop and I am going to check, friends. While if array of L is equal to 0, as long as if that element is 0, you keep on increment your left pointer or low pointer, L plus plus. You no need to do anything. You keep on increment L. Whenever if you see ARR of L is equal to 1, you have to stop. Okay. Similarly, I will come from the right hand side. Now see friends, right hand side, if 1 is there, then no problem. You decrement. 1 is there, no problem, decrement. 1 is there, no problem. But when you see the 0, then the problem. So you have to stop it. So what will happen, friends, here? While ARR of R is equal to 1. So as long as if that element is 1, you keep on decrement your R value. You keep on your decrement the R value. Okay. Yes. Now see, friends. Now see. So as long as this is L, we are keep on incrementing 0. As long as this is 1, we keep on decrementing. Okay. Now we have reached here, friends, and we have reached here. Okay. So now what we should supposed to do, friends? We have to swap this one and this one. We have to swap. Correct now? We have to swap. Okay. So what we will do? But before swapping, friends, we have to check that L should be less than R, right? On the safe side, because they both should not cross each other. Both should not cross each other. Okay. So we have to swap. So to take temp. So ARR of L, you keep this. Then ARR of L is equal to ARR of R. I hope you know this code, right? Swapping ARR of R is equal to temp. Right. So taking third variable for the swapping. After swapping, what we have to do, friends? We have to increment our L and we have to decrement our R. We have to decrement our R. So let me minimize this. Okay, cool. So let's continue, friends. So L, which is stopped here. So finally, what will happen? So here 0 is coming and here 1 is coming. and 1 comes here. Next time, L will be incremented and R will be decremented. So L will goes there and R will comes here. R will comes here. Okay, cool. Next. Again, you check, you come to this condition. As long as if this element is 1, you keep on going forward. Listen my words carefully. Listen my words carefully. People, are you not listening to my classes? Somebody is asking, what if I keep if? What if I keep if statement instead of while? What I am telling, as long as if the element is 0, you keep on moving forward. As long as element is 0, you keep on moving forward. Keep on move forward. Now, if condition, how many times it will check? Tell me. If condition, it will work as a loop. If condition will work as a loop, it will check more than once. Here, do I need to check more than once or I need a repetitive process? I don't know where you will keep your brain. Next time, if I get such nonsense questions, I'll throw it from the class. Literally, I'm saying I'll throw it from the class. See, now how much is the time? Now the time is, if you see, 11. Now the time is 11. Can you tell me, when should I discuss 2-pointer another direction? Still we are at opposite direction only. Now, when should I discuss the 2-pointer moves in the same direction? I won't get a time. I'll simply leave. Friends, because there is no other class. Only one class is given on the 2-pointers. Only one class is given on the 2-pointers. See, somebody is saying, sir, it's a time complexity order of n square. It's a time complexity order of n square. Somebody written. 1 minute. So, Sahil, can you unmute and tell me how it is n square? 1 minute. Where this fellow? Snehil. I make you to unmute. Can you tell me how it is order of n square?
So here there are 2 loops running from 0 to n, right? First one is L. L less than R. So the worst case scenario is that the R is still on the last index. And here in the second loop, suppose there are no ones, only zeros are there, then the loop will run till the last index.
What you are saying, only ones are there.
No, only zeros are there.
All zeros. That's what you are saying. All zeros are there.
Yep.
Where L will be pointing? L is initially. No, wait. L will be pointing. Others, please stop commenting. Listen carefully. L is pointing here. R is pointing here. Okay.
Yes.
Now tell me, L is less than R. So all zeros. Now where L will goes to? Last.
Last element.
After that, what will happen?
Sir. So, sir, there are 2 loops now. First one.
Just answer my question. Okay.
Yeah.
As you said that while L is less than R. Okay. L is here, R is here. So in the same way, what you told, as long as if array of L is equal to 0, I keep on incrementing.
Yes.
Okay. Now tell me next what will happen.
Sir, as there are no ones, no swapping will be done and it will exit the loop.
How many times this loop is running?
N times.
Then why you said order of n square? By how you said that order of n square as answer?
Okay, so the first loop is running for only 1 time. Oh, sorry, sir. I just got confused.
No, don't say sorry. I will feel bad actually if you say sorry. See, it's not only to Snehil, friends. Every student who was attending the class, I'm telling, whenever you are saying time complexity, please analyze. Please analyze. Without analyzing, if you directly told the answer now, straight away they will throw out from the interview. I'm telling now. So Snehil, don't feel bad. It's not for you. Everyone I'm telling. Without analyzing, if you tell the code, directly they will throw out from the interview. They won't even spend extra 1 more second also with you. You only write this code. And you told that its time is order of n square, which means they'll clearly get that this fellow don't know basics of time and space complexity. and they'll easily get to know this guy by-hearted the concepts and came to the interview. Okay, I'm telling now. I'm telling now, friends. So kindly, my suggestion is, please go to time complexity videos again. If it take extra time also, listen those videos again and understand how to analyze the time complexity. We spend almost 1 week on that. 1 week we spend almost. Okay. I hope you are getting. Don't say I am angry. Understand why I am angry actually. Because I spent this much amount of time. What is the use? Tell me. You think from your side. I spend 1 week on time complexity. I promise the DSA team I will make these fellows strong at time complexity. What is the use? People are from my old students who are in 401, 501. They are asking, sir, please come to us. But I told specifically to 201, I took it to make these concepts clear. So don't take me as an angry way. I'm for your benefit. I'm telling, right? Whenever you are analyzing the time complexity, you are telling blindly. Don't say. Take some input array. Try to think in different directions, and you have to say. If you are not doing this now, I'm telling the friends in interview, you are in lot of trouble. You are in lot of trouble. Okay. So if you take me in the positive way, your future will be good. Otherwise, it is up to you. Otherwise, this is up to you. Okay. Somebody is asking, sir, why L is less than R again here? Somebody is asking, why L is less than R again? Array, if you see here, L of I, as long as this condition is equal to 0, you will keep on exit the loop. Then before swapping, don't you check we are on the safe side or not? Now assume once if this while loop is over, as long as ARR of I is equal to 0, L will go to array, right? Then this condition will definitely execute it, right? So L less than or if you are going like this, somewhere if you are middle, if you are there here, if you did not check straightforwardly, if you write without checking this condition, if you straightforwardly write, don't you think that it will give array out of bound exception, or you are found out of that array? Tell me that person, who is that fellow? Rajendra. Tell me, don't it won't give array undefined or not? If you did not keep this condition, friends, L less than R. Okay. If you did not keep this condition, okay. Now my ARR of R is L is pointing to the last element, right? Then where is ARR of L? If you blindly execute this, undefined it will give. We didn't even enter the condition. Now see this. L is pointing here, R is pointing here. Okay. L is equal to 0, increment. While L is less than R, true. I am coming inside this while loop. So L, keep on going like this. When L will be pointing here, where you are checking while L is less than R or not? Are you checking anywhere here or here? Are you checking? You are not checking. Then L will be incremented. Now that fellow is saying, yes, I got it. First time you did not get it, huh? Tell me. I don't know where you people are there. Okay. L less than R. If that is like this, if you are like this, means very difficult, friends. I'm telling you now, very difficult. L less than R. Okay. So inside we have to write if L. So wherever you are checking, anywhere you are checking now. So you should be do this cross check. That is, if L is less than R, then only you have to stop. This is a condition. This is the condition. Okay, everyone getting? This is the final code. And start building a habit of doing dry run. Start building a habit of doing the dry run. Cool. So we'll go to next question. Now I hope this is clear. So you take after the class, take pen and paper and do the dry run by taking these examples. Now overall, what is its time complexity? This loop will run n times, no doubt in that. But if it is running n time phase, it will run either one time or one time. Or if it is running only one time, then either this loop runs for n time or this loop will run for n time. So overall, what is this time complexity, friends? Order of n. It's not a order of n square. Okay, order of n is the time complexity. Whenever one loop inside another loop is there, it doesn't mean that blindly I will take its time complexity n square. No, that is false. You have to do the analysis. Analysis is most important. Getting everyone? Cool. So the next question. Reverse the array which is in place. Now, what about the space complexity here? Are we taking any extra space apart from given array? Order of n is the time complexity. And apart from given array, are we taking any extra space? No, no extra space. Temp I am taking, but these are the variables now. Constant space, friends. These are all the constant space. Therefore, space complexity will be order of 1. Order of 1 is the space complexity. Right? Okay. Next question is reverse the array. And here I have used one word called as in place. In place. So in place meaning is you should supposed to solve this question in order of 1 space complexity. That is the meaning of in place. So in place means space complexity should be order of 1, which means extra space you should not supposed to use apart from constant variables. So again, if you reverse the array, what will the output looks like? 17, 11, 8, 21, 6, 9, 4, 7. This is the output. This is the output. Okay. So can I use last approach here? Already some students are saying yes. Same, friends. Take one pointer L here. Take another pointer R here. You swap. Now here, no need to use the while loop. No need to use any while loops here. Just to only one outer side while loop is enough. So you swap ARR of L and R. So 17 will come here and 7 will goes there. Then increment L and decrement R. Again, swap them. If I swap, so 11 will come here and then 4 will goes there. Again, you increment L and decrement R. Swap them again. So 8 and then 9. Then increment L and decrement R. Swap them again. Then 21 will come here. 6 will goes there. You decrement the R and you increment the L. Whenever they are crossing each other, we have to stop. So condition will be L less than R. So I hope getting everyone simple. So one simple while loop, you can able to solve this. What will be its time complexity? What its time complexity? Order of n, friends. Order of n. Yeah, it even used for the strings also. Yes, for strings also you can use this. So string is nothing but a collection of order characters, right? Okay. What about space complexity? Order of 1. Order of 1. Okay, yeah, palindrome check, same. Okay, so now so far we have discussed all the questions based on 2 pointers, which is pointing to one is beginning index, other is last index, and how they were moving. L is moving like this and R is moving like this. Opposite directions, they both are moving, friends. L is moving like this and R is moving like this. R is moving like this. Okay, but next we will see the 2-pointer second model, that is what if they both are moves in the same direction? What if they both are moves in the same direction? Okay. First question I am going to take here is, first question, very interesting, important question. This is merge 2 sorted arrays. The question is merge 2 sorted arrays. So here the question is, friends. So 2 arrays will be given. Both arrays are sorted arrays. This is first array, which is sorted array. This is the second array. This is also a sorted array. Sorted array. Now first array whose size will be 5 elements. N1 will be 5 and Second array n2, whose size will be also 5. Final output should supposed to look like the final sorted array. Now, this is individually, this is sorted 1, 3, 5, 7, 9. Second array, this is also individually sorted. But now final output is overall, you have to sort the given array and you have to produce the output. Okay, so like 1, 2, 3, 4, 10. So this is 1, 3, 5, 7, 9 and 2, 4, 6, 8, 9. Overall, this is 1 to 10. So is the problem statement clear? Any doubts are in this? So two individual sorted array, we have to sort into final. Final output should supposed to looks like this. So merge two sorted arrays. So individually, two sorted arrays are given. Finally, you need to return the sorted array. Sorted array. Right? Now, let's see how can you solve this question. Okay. Maybe one simple solution is you take some random array, temporary array, and try to put all the elements of first array here and try to push all the elements of array to here and apply sort on this. So have anyone got this idea? Put all the elements from here and put all the elements here and then finally sort this. Right. But if you write like this, I hope you know what is the response from the interviewer. Right. I hope you know the responses, right? I no need to say it again. Now, different approach, friends. What is the merge procedure? Merge procedure. You should supposed to know. Listen carefully. This approach will be used in the merge sort. When you are studying the merge sort, this approach you are going to use, friends. Merge sort. Okay. Later units you are going to study. Again, you are going to encounter this. So first array n1, number of elements are 5. And second array n2, number of elements are 5. Now, I am going to create a third array. So ARR3, I am going to create, whose size will be n1 plus n2. So if you know the size, I hope you know how to create the array. Yes, I have created an array. Now, I am going to take total 2 pointers. So pointer I, which is pointing to index number 0. Second pointer, which is pointing to the last element. And third pointer I am going to take, which is pointing to index number 0. So friends, initially I also equal to 0 and j is also equal to 0 and k is also equal to 0. But I will be pointing to the first array ARR1 and j will be pointing to the second array and k will be pointing to the third array. 3 different pointers. So 3 variables I have taken. Now, so you have to compare ARR of 1 of I versus ARR of 2 of j. You have to compare. Now listen carefully. Now this one you have to compare. Among these two, which one will be small? This one will be small. So try to put this element here. After keeping this element, you simply increment this I, because you have brought this one from the first array, right? Therefore, I have incremented this and you increment the k value also. Increment the k value also. Next, compare ARR of array 1 of I and array 2 of j. Now, among these two, which one will be small? 2 will be small. Therefore, try to keep this element here. And since you brought an element from here, now this 2, therefore, increment the j value. And next variable, next time you have to give an empty space. Therefore, increment the k value. So till now you got it, everyone. Again, same story. Compare array 1 of I and array 2 of j. Now, which one will be small? 3 will be small. Therefore, you keep this 3 here and you increment your I and you increment your k. Okay. Again, same. 5, 4. Why 5? Because I is pointing to index number 2. J is pointing to index number 1. This 4 will be small. Therefore, keep this small here and you brought this 4 from the second array. Na? Therefore, increment the j. Increment the j. Now, again, you have to increment the k as well. K as well. Next friends, 5. So 5 will be small. You place this 5 here and you increment your I, then increment your K. Increment your K. 6, C small, therefore, so increment the J. Like this, you can repeat the process. So friends, while crossing this array I, similarly while crossing this J, you should be careful about I should not supposed to cross the boundary. So I should be strictly less than N1 and J should be strictly less than N2. Getting everybody? Because you are comparing array 1 of I and array 2 of J, friends. So that is the reason. So make sure that this I should not cross this boundary and this J should not cross this boundary. What will happen if it cross this boundary? For example, if I reaches to index number 5, then when you are comparing array 1 and array 2 of J, so where is the element? Not exist, right? So it will give an undefined friends. That is the reason I should be strictly less than N1 and J should be strictly less than N2. Okay. Now how this code looks like? Simple, right? So both of length can be same or different, no problem. Both of these length can be same or different, no problem. So function fun. So array 1 will be given and array 2 will be given and N1 will be given and N2 will be given. So first array, what is its size and elements? Second array, and what is its size and the elements will be given. So first, what I told friends, you have to create a new array, ARR of 3, and what is its size? What is its size? N1 plus N2. I hope you know. I told in my first class only. What is this? Right. So array size of N1 plus N2. Array size of N1 plus N2. You cannot write AR. You cannot write something like this. Aisa, you should not supposed to write this, friends. You know the reason why we cannot write like this. Because if you know the size of the final output array, why you are declaring this with size unknown? Better to write like this. Now, while so here I'm going to take 3 variables. I is equal to 0, J is equal to 0, and K is also equal to 0. Now, I should be strictly less than N1 and J should be strictly less than N2, right? So I'm going inside. Mostly this 2-pointer will goes like this only, while loop maximum. Okay. Now come here. So compare array 1 of I and array 2 of J. Now see friends, if array 1 of I is small compared to array 2 of J, then inside that array 3 of K, we have to keep the array 1 of I, correct? Correct, friends? Inside array 3 of K, we have to keep the array 1 of I. Then we have to, now I have to increment the I plus plus and I have to increment the K plus plus, correct? Okay. Next, if this is when the first element will be small compared to this, otherwise, else array 3 of K is equal to what I have to write here? What I have to write here? Very good. Array 2 of J. Array 2 of J, friends. Okay. And then J plus plus and then K plus plus. K plus plus. K plus plus. Right? I hope everyone understood. Everyone understood, friends? Simple. So happily, all these elements will come here. All these elements will come here. Finally, it is going to get sorted. Finally, it is going to get sorted. What if array elements will be same? There might be another condition, friends. ARR 1 of I is equal to J. Now, try to activate your brain and think. You will get that answer. Try to activate your brain. I'm saying again, try to activate your brain. You will get that answer. After the class, you take the same code, you execute it. You will get it. You will get it. Why to write continue? I told you to activate your brain. Why to write continue? Else block will run, right? Else block will run, right? It is going to handle, right? Obviously, if this is false means it will going to handle. Else will take care about that. That's what I'm saying. Now you are saying correct answers. Now you are saying correct answers. When I said activate your brain, before that, your brain got dead. Huh? Your brain got dead, tell me. Or your brain is rotating around your girlfriend. Maybe you might have promised your girlfriend that within 6 months I will get a job and I'll ask your father to give that something like, right? You promised their girlfriend dad, within 6 months I'll get a job. If this is like this means, then your girlfriend will get married to some other guy. Because in 6 months it won't happen. If your brain is working like this, it's not possible to get a job in 6 months. Girlfriend will see another guy. This is truth, friends, because I had a 17 batches of experience. I'm telling with my 17 batches of experience, I'm telling to you, if your brain is working like this means it's impossible, right? So activate the brain, right? Okay, cool. Now tell me, friends, with here you might be thinking that my code is done, but there is a one handle case is there that we have to consider. One corner cases are there that we have to consider. And let me tell you what is that corner case. What is that corner cases, right? See how beautifully I have written all those things before the class, right? Okay. Now, 2 arrays I have taken, friends. 2 arrays I have taken. So this is the first array, ARR of 1. First ARR of 1. And this is ARR of 2. Again, this size can be equal or not equal, no problem. First size will be N1 equal to 5. Second size will be N2 equal to 5. It can be equal or not equal, friends, right? So I will take I here, and I will take J here, and I will take K here. Now listen carefully. From the previous code, we compared ARR of 1 versus ARR2 of J. And I should be less than N1 and J should be less than N2, right? Now I am coming here. Now compare this one and this one. Among these, whoever will be small, that value will becomes here. Then I will be incremented and then K will be incremented. Okay. Next, among this one and this one, always compare this array 1 of I and array 2 of J only. Remember, friends. Then among these, who will be small? This fellow will be small. Therefore, this guy will come here and then K will be incremented, as well as because you brought these 2 here now. Therefore, this variable will be incremented. Same this code only I am explaining. Okay. Now 3 and 4. Obviously 3 will be small. Therefore, this 3 will come here and K will incremented and then I will be incremented. Now see, friends, this is 10 and this is 4. Obviously 4 will be small. So 4 will becomes. Then K will be incremented. Then again, J will be incremented. Because you brought this 4 from here now. Therefore, this J has to be incremented and this K has to be incremented. 10 and 5. Obviously, 5 will be small. So 5 will becomes here and K will goes there. Then J will be incremented. Next, 10, 7. Obviously, 7 is small. Therefore, 7 will becomes comes here and then K will be incremented and J will be incremented. Now, next 10, 9. Obviously, 9 is small. 9 is small. So K will be incremented and J will be incremented. Now tell me, friends, still my while loop will run or my while loop will fail? My while loop will run or my while loop will fail? Obviously, my while loop will fail, right? Okay. Then one of our hero is saying, instead of and, he is saying you to use the R operator. R operator, he is saying. Okay. Okay. I have used the R operator. Still, this condition is true. If that condition is true, next time, is there anything to compare ARR2 of J? Tell me. Is there anything is there to compare? Tell me. Don't you think compiler will give left and right to you? Your OJ or your Replit, don't you think it will give left and right? Left side one slab and right side one slab. Array waste fellow, your J is pointing to last, which is out of the bound. Then where you will compare this one with this? Don't you have brain? Will tell. Right? Or else your girlfriend will get married to some other guy. Some other guy. Right? So therefore, this is you have to keep under operation only. You have to keep under operation only. Right now? Then next what to do? What to do next? Right. So this array is completed, friends. We have compared all these elements and this is done. Then there are some elements who are left in first array. Am I correct? Couple of elements who are remaining, right? Therefore, those remaining elements are there. We have to place here those remaining 3 elements. 3 locations are there. We have to keep all the remaining 3 elements. Therefore, after this code, we have to continue. Is there any elements are remaining in the first array? If yes, you have to copy the remaining elements from here to here. See, there might be another case. What is that case? All the arrays of first elements are over. Couple of elements are left in the second array. This is another example I have given here. That can be also possible, right? Therefore, again, second loop you have to take and verify any elements are left in the second array. That one we have to keep it in the next array. I hope you understanding, friends. What is the problem with this code? This code will work fine, no problem. What if there are some other elements are remaining? What if some other elements are remaining? Those elements we have to copy paste. Those elements we have to copy paste. Right? I hope, can you continue this code? Will you continue, friends, this code? So simple, 2 extra while loops you have to take. 2 extra while loops you have to take. And any remaining elements are there. Those remaining elements you have to copy. So copy remaining elements. Copy remaining elements. Copy the remaining elements. So this is the how 2 loops. One loop is for this one and another loop is for this one. Simple. One loop is for here. Try, if you are not getting, next class I'll explain the remaining part of the code. You try on your own. So this one, friends. Right. Okay. So that's it for today's class. I think now one more problem is there, but time will not be sufficient. Next class I'll discuss another question on 2 pointers moves in the same direction. Now, if you see, friends, I is also moving in this direction and J is also moving this direction. Correct? Okay. Yeah, I'll add all these questions in your OJ. Don't worry.